AI, machine learning applications, and how geospatial data preservation has a role in it. This is, I think, the only thing that was left from the Zagreb idea, where they said that in Zagreb we should create a DLM forum that will talk about usage of AI and machine learning technologies in the archival domain. After that, we will have a short break. So we estimate that we will finish a short break 11:50 and 11:55 to continue with the DLM forum members meeting that will be in the last half an hour. And the goal of that meeting is to discuss the future actions of the Geoforum, possibilities of your engagement, and to somehow define the priorities where we should go with this initiative. So next, I would like to tell you more about the rules of engagement. So, because this is an online event, we need to set some ground rules so that everyone gets all the information they need, and we can actually present in peace without distractions, or with as little distractions as possible. So we have our kind Kristi Otz from the DLM Secretariat who is assisting us with the questions and technical issues. So if you have any questions, please write privately to the DLM Secretariat Kristi Otz, and she will help you with it or answer you with it, because the presenters could be disrupted if they get some public chats online. Also, I need to say to everyone that this meeting is recorded, so if you're going to talk, you will be recorded on, and this recording will be available to DLM members to view in a later time. So if you don't want to be exposed, just write a message or write an email to people at the end. To save bandwidth, I would, and to save us from distractions, we will ask you to turn off your camera if you're not a speaker, and we will try to answer to you in any other questions that come up. Of course, our presentations are scheduled for 30 minutes. In this 30 minutes, approximately 25 minutes is allocated to the presenter to present their presentation, and then we have a 5-minute window to ask questions for speakers. Because this is an online event, we would like to ask you to send your questions in advance to Kristi, to chat, to her chat, and she will ask them online. And because we know that sometimes there is more questions than there is time, send your questions anyway, even if they're not answered online. We will address them in a later document, and we will ask the presenters to answer the questions and publish the answers to those questions in a Q&A section that will be a part of their PowerPoint that will be submitted and available online. So by doing this, I finished my introduction, and I would like to kindly invite Mr. Zoltán Szatucsek from the Hungarian National Archives to prepare his presentation while I tell you more about him. So Zoltán is going to present a presentation on the visualization of the travels of the European emperors. Where did they travel around? And Zoltán is a senior archivist in the National Archives of Hungary. He's the director of international relations and EU project department. He studied history and philosophy in Debrecen and holds an MA in history from Debrecen University. In the archives, his professional fields are electronic records and digitization with extensive experience in large-scale implementation projects. He is an active member of several professional working groups and committees at both national and international level. He represents the National Archives of Hungary as a director within the DLM Forum as a governance board member. So without further ado, please, Zoltán, start your presentation.
Thank you, Gregor, for this introduction. I hope you can hear me well. Confirm, please. Okay. So, in these extraordinary circumstances, we have to learn new skills. For example, this new skill is how to have a conference online. So this is my first this kind of online presentation after. So please be with me generous if I make some mistakes. The project what I would like to speak about is actually a loved one. So all of the people who worked with that, I experienced they did it with really big enjoyment, really big fan. So I hope that the outcome of this project is also will be at that level. The idea, oops. Okay. Sorry. Okay. So can you see the shift on the?
Now we see your presenter's view. So just change it.
Okay.
Now it's okay.
No, it's okay. So first of all, the reasons why we started to do this. So you have to know that in this digital age, the archives, cultural institutions are struggling how they represent themselves. Especially, particularly for the archives, there is a high demand to remain relevant in the digital age, relevant to the society and provide meaningful services. So this is a new challenge. How can we express our holdings in a way to cope with the demands of the society? We have mainly textual documents, not too impressive for the audience. So we have to find new ways to represent ourselves, to visualize the data what we have, immense data in the public archives. New way of uses of this data. We have to support the education. There is a expectation to give data to the creative industry and also support applications for tourism. And we also have to maintain, and it's a great strength of the archives, because they were always regarded as local credibilia, the place of the credible information. And we have to use this strength in order to share our data with the public in a credible way. So what we like to do in the National Archives of Hungary to develop some services which are fit with these conditions to provide more meaningful services for the society. The pragmatic thing what we started to develop this application is the anniversary of King Matthias 2 years ago. And we got some small funding from our ministry in order to commemorate of this anniversary. And we used this funding not only for having a conference or just small events, but also wanted to have something more tangible, more permanent. So the outcome was that we developed a service on the travels of King Matthias, contained 1,500 records approximately, and the travels, the locations of the travels of King Matthias and his wife, Beatrice of Aragon, the Queen. This database contained 1,103 references to original documents, which was very important to publish our documents this way. And the time span was the second half of the 15th century. This project was a kind of micro project. So the development lasted only 3 months, and the money what we used for it was really almost nothing, invisible amount of money. I can't remember exactly the sum, but it was between 1,000 and 2,000 euro. And the success was immense. So a lot of people wanted to use it. A lot of people was impressed by the visualization of this geodata, and we decided to continue. Of course, the obvious way of continuation was to put more people, more persons into the database, more kings, rulers, prominent persons, because we have travel data mainly from prominent persons. So as the result of this development, which was longer than the previous period, and we worked on that from the beginning of 2019. So now we have more than 10,000 records, and 9 persons, kings, queens, rulers, emperors included in this database. Many of them are European rulers, so have not only, so we have to change the focus of Hungary into a European wide. We have more than 2,000 references for the original documents, and this time not only from the collection of the National Archives of Hungary, but 18 different collections around Europe. And of course, the time span is also extended, because the first ruler who is included in the database is Sigismund de Luxembourg from the late 14th century, and the last one is Joseph II, the Austrian emperor, and his data is from the late 18th century. It is an important part, because we couldn't use directly the archival sources to identify the travels and places of the kings. It's a methodological problem, which could be represented by the fact that the early rulers had a very improved administration, and the image of the medieval bureaucracy led to that the signatures or seals of the rulers cannot be identified, the places where the given ruler was. So the chancellery, the bureaucracy of the kingdom, issued charters, issued diplomas, issued donations on behalf of the name of the king or the ruler, and it needs a historical research to identify where the given person actually was. So we couldn't use the database with the date information of the archives only, but we have to use the books, studies, and monographies of the historians. So this is the sales, and there are a lot of controversies, and this is one of the use case or the outcome of this database, that it could help the historians to identify or find controversies in the travels. For example, if they found that a location of the king or the ruler was 200 kilometers away from the location when he was the day before, it must be something wrong. Maybe the diploma was fake or was issued by a different person. This was the first challenge. The second was to identify the historical geonames, because a lot of things, a lot of issues are related to this identification. The locations of the first one is that the locations of the original source are ambiguous, so it's not easy to identify which is the place which is mentioned in the original source. Many times we have to find that the same names used for different locations, which is so today the geographical names are much more can be used much more for unique identification. But in the medieval ages, a lot of settlements were named after their churches. So there were a lot of Saint Nicholas or San Juan settlements with the same names, and many of them are with a narrow area, the same region. So, for example, we have the settlement Becce, 5 places in south part of Hungary, and also in Croatia, Slovenia, Bosnia, and Serbia. And of course, the current names and the current gazetters, when they, in which they can provide the location, the geocoordinates, are in the current languages. So we also have a language problem with this. Not easy to find these places because they might be in a very broad location. My favorite example is Strasbourg, which is a settlement in Ukraine, and obviously we had to identify that Sigismund of Luxembourg wasn't in Ukraine in the 14th century, but of course in Europe. And administrative changes has also impacted this identification because small settlements sometimes merged with big cities, and many times we don't have the geolocations of these settlements. So it was really time consuming and needed a lot of effort to identify these historic name places. And because in the database there are a lot of them, more than 1,000 settlements, we have to use for the geolocation algorithm. We use a Python script to identify the locations and help to identify these places. We use the Getty gazetteer in order to find the coordinates, and we also had to narrow the places using shapefiles in order to identify that name, a geoname, is in the same location as it must be by the original sources. So, for example, in the case of Sigismund of Luxembourg, he must be in that region in that time. So if you have several names, several location names for the same database, we have to narrow it by the region. The outcome was a probability index, and we use, I don't know whether you can use it. Okay, yes, we have to move the screen. So with the probability index and the ambiguous cases, we had to identify the place manually by the decision of the archivist. And it was a really big job, especially particularly for the Spanish King Carlos. And we had a lot of help, actually, immense amount of help from the Spanish colleagues particularly from Joaquin Perez. Thank you, Joaquin. Oh, okay, and now, before I go to the laudation, I would like to show you the service itself. So the project is expected to be finished by February, but unfortunately we had some delay due to this extraordinary circumstances. So the launch is now expected by June. I have to move this bar. So this is the opening window, and you can see that the user interface is multilingual. So we will choose the English version for this presentation. And what you can see now are the travels of King Matthias. I will shift to Sigismund now. So you can choose the rulers from here, and you can see that there are 9 persons now included. And you can see the travels represented by dots and arrows. In order to better visibility, I switch off the arrows, and you can see the spots where Sigismund de Luxembourg traveled. Each dot represents one settlement, and of course, one settlement you can see several visits. For example, in Prague, Luxembourg, Sigismund de Luxembourg were many times, lots of times. The one dot represents one place, and the size of the dot represents that how many times, how frequently visited the how frequently the ruler visited that given place. The color of the dot is also meaningful, because you can see a timeline bar here. You can narrow the travels by time. Of course, if I pull it to, then we won't see anything, because the time period of Sigismund de Luxembourg was the late 14th, early 15th century. But I can narrow the time period with this bar, and then we can see less locations. I would like to show you some additional features, and I will use Carlos for this. Of course, I have to adjust the timeline because he was a 16th century emperor. Okay, we can see a lot of dots now, and with this search box we can search for settlements. Zaragoza is a Spanish city when Carlos was many times, and you can see that in this location in Zaragoza, Carlos was, I don't know, 7, 8 times, and you can see the details of his visit by clicking on one single spot. And you can see the details of the footnotes of the original book. And you can even have the connection to the original resource, the original archival or library resource. So this link leads to the Spanish National Library, and you can see the book when this location, when this travel was mentioned. Okay, the internet connection is a bit slow, so I go on and I try to show you another link, which is from the catalog of the Spanish National Archives, Spanish State Archives, and you can see the archival record here. You can click on it so you can see the details of the records and the digitized version as well. The reason is why we don't we didn't want to translate everything is this, that I can very easily switch to Google Translation, and it's very meaningful. Unfortunately, not so good in Hungarian language. I go back to the itinerarium now, and yes, I would like to show you one last thing with this itinerarium. That there is a, and I will use Sigismund again. So because we have an animation of the travels, and I narrow the timeline. Okay, we will see his travels now.
No, we don't see any travels.
Okay, I did something wrong. Okay, I try to switch. It again.
It's probably because you have Zaragoza inside, so maybe it's just looking for that.
Oh, thank you, Gregor. Because yeah, I narrowed to the search term. Okay. So I narrowed the timeline in order to show you how this animation works. So normally we have the dots of Sigismund de Luxembourg now. Okay, and if I start the animation, we can see how he traveled from one place to another one. Okay, so I think, and you can see the each locations how he came from Buda to the next place, Tata, and to Bratislava, to Sopron again. I would like to show you how can we use it for education purposes, and I will show you it with in the case of Matthias. So Matthias was a legendary king. A lot of fairy tales related to his names, and is very popular in Hungary. And one thing which are also discussed by the historians, that in the early period of his ruling, he focused on the fights against the Turkish. So you can see from this map that most of his travels were to east and south. On the second period of his ruling, he focused much more on the Western diplomacy. And you can see that his travels are mainly toward the Czech kingdom and to the Holy Roman Empire. His ambition was to have the crown of the Holy Roman Empire. Okay, so this is what I would like to show you about the service, and I would like to return to the presentation now.
Yes, because we're in the last 5 minutes of the presentation. So I hope there won't be too many questions.
Okay, so we have, it was a collaborative effort of a lot of people, historians, designers, archivists, with different background, and different kind of skills. For example, the lead designer who started with the first project didn't know anything about the methodology of historical research. And the other way around, the historians, the first historian who started to work with us was a real anti-talent of computers. So, but everybody was so enthusiastic that this collaboration had this fruit. So, thank you for everyone who participated in this project. I told before that we wanted to launch it in February, but we can see now the end of the tunnel. So we have some minor issues with the databases and also with the user interface, but it is expected to be launched in next month. We would like to add some new features like filter for the archives and collections, and in the future we would like to add more rulers. So every feedback is more than welcome, either on the issues, the bugs, or ideas for new features or providing new data for us. Thank you for your attention. I'm ready for questions.
So the first question I already got was from Jerzy Morzek. Is this a publicly available site already? And if yes, what is the link?
Okay, so I will provide the link for King Matthias, which is available now. For the other rulers, it will be available in June. So this is the service is on the internet now, but it's protected by password in order because it's a test version only.
Okay. Now, Christy, did you have any other questions for Zoltán?
Yes, we have received one question from Ann-Kristin, and it's about the background maps. Are the background maps with borders used in this service preserved in the archive, or are they downloaded from a map agency?
Okay, it was also a challenge which I didn't mention. So it was a problem and a long discussion what kind of maps we have to use. We wanted to use contemporary maps first, but they weren't accurate enough in order to use. So we, for example, the first ruler is Sigismund de Luxembourg, as he's from the 14th century. So 14th century maps were not accurate enough to use current geolocations with them, particularly to combining with other rulers from other ages. So we used contemporary maps only to identify the borders, and we use current map for the rivers and natural geographic objects.
Okay, thank you. And I guess this is our time for the questions. If anyone has any other questions for Zoltán, please send them to Christy with referring to Zoltán's presentation. And Zoltán said he would answer them later, so we can include them into the questions and answers portion of the slides that will be uploaded to the DLM forum website. So thank you very much, Zoltán. It was a very...
Sorry? I have an idea.
Yeah.
Maybe people want to watch it now. I can share the link and the password now, and of course we will change the password because it's a test version and we don't want to make it public.
Okay, then just publish it into the chat for everyone, so everyone can see the parameters. And I hope they will still listen to our next presenter during browsing of your webpage. So thank you very much, Zoltán. And now we are going to a more recent experience of the Danish National Archives. Our next presenter is Ann-Kristin Egeland, who is a special consultant in digital preservation at the Danish National Archives. For 10 years, she has prepared AIPs with data from databases for access and is now responsible for the preservation format of Geodata in the archive. She's a candidate in computer science and history of arts from the Roskilde University and a master in interaction design, and multimedia from the IT University of Copenhagen. So I would now kindly invite Ann-Kristin to present their experiences with Geodata archiving.
Yes,
Please.
thank you. Can you hear me?
Yes, we can hear you and we see your presentation.
Okay, thank you. Yeah, as Gregor just said, I'm not a geodata specialist by profession, but I have worked at the Danish National Archives for 12 years, and I'm responsible for the preservation format for geodata at the archive. And I'll slide. And today I'll tell you about 10 lessons that we have learned during ingest, preservation, and access to geodata in the Danish National Archives. And I will also give you an overview of the different types of geodata systems or data sets that we see in the Danish public administration. And then I'll outline some of our future challenges of choosing suitable preservation formats for all of these types of geodata. And finally, I will illustrate how our experiences can serve as an input to the E-ARK geodata specification. And I'm very well aware that the Danish National Archives have the advantage of being able to require that the geodata submitted to the archive should be submitted according to specifications that we define. And of course, our experiences will reflect that. And also, we use the migration strategy and in a way that the data creator must migrate to our specifications for geodata during delivery to the archive. And not all archives or preservation agencies use the migration strategy as we do. Maybe you embrace the emulation strategy, or maybe you migrate later on in the preservation process. But despite these differences, I still believe and hope that our experiences can be of value to you. At the Danish National Archives, we have ingested geodata for the last 10 years, and now we have 30 archival information packages with geodata in our collection, and they only contain vector data, and it's very small data sets. But we expect during the next 3 years to ingest 40 more submission information packages with geodata. And among them, I think 9 of them will be large raster data sets as well. And in the former slide, I just used the concepts of vector and raster data, and this slide shows you the difference and illustrates these concepts. Geodata often comes like either vector data or raster data. And in a vector data set, the coordinates are represented by a point or a line or a polygon. And a line could be the measurement of a road, and a polygon could represent the area of a lake, for example. In a raster data set, there's also a vector coordinate connected to a raster image, which makes it possible to place it on a map. And a raster image could be a digital photo of the Earth or country, or it could be a grid file. And I won't go into detail, but now you know what I'm talking about. So let's start with the lessons learned. The first lesson I will share with you is that at the Danish National Archive, we only allow few coordinate and reference systems in the ZIP and in the preservation format. And the reason for that is that information about transformation algorithms between older and new coordinate and reference systems are, we think they are very hard to preserve and if you don't really have it, to create yourself. And it's quite complicated to implement them in the migration process as well. The coordinate and reference system you see here, the ETRS 89 UTM zone 32N is the coordinate and reference system that we allow in our preservation format. And this slide here, you can see an example of a coordinate and reference system, the one that we use for Danish data, geodata. The information about the coordinate and reference system that fits the measured coordinates is very important to preserve, because this is the information that ensures that the coordinates are placed correctly on a map when you view them in a geographic information system. And there's a lot of different global and local coordinate and reference systems because you can map the three-dimensional globe onto a two-dimensional map in many different ways. And this mapping from a 3D to a 2D is called a projection. And the picture you see here is the UTM projection, which divides the surface into 60 zones, the surface of the Earth into 60 zones. And to this projection, there's also information about the unit of measurement of the coordinates, whether the coordinates are measured in meters from axes or seconds or degrees. And that unit of measurement depends on the projection used. And in the UTM projection, the coordinates are measured in meters from a north and an east axis in this coordinate and reference system. And finally, there's this concept of a datum, which is the mathematical model of the part of the surface of the Earth to be measured. And it's this model that makes it possible to place the measured coordinates correctly on a map. So these three information is important to preserve when preserving geodata. Yes, and this citation is from an article by the Danish map agencies, and it illustrates the challenges of developing a transformation algorithm. And it says it has been a huge challenge to re-implement the old coordinate and reference system because of lack of documentation. And to make the transformation algorithm, we had to understand the old source code, and several times we had to interview former employees to understand the difference between the old and the new coordinate and reference systems in details. And that's just to stress the point why we at the Danish National Agency only allow very few coordinate and reference systems, because sometimes you just lack documentation of this coordinate and reference system and the transformation algorithm needed to convert to newer and more used coordinate and reference systems. Another lesson that we have learned is that users need background maps when they use geodata, because it's quite hard to use these data without a background map. And and then you, again, as an archive, you can ask yourself that if you allow all the original coordinate and reference system used out there in the real life, can you provide these background maps for the user in the future in all these different CRS. This is just to illustrate why we need a background map as a user of geodata. What you see here is the content of a GML file with vector data, and you see a lot of protected areas. But where are these geodata placed? It's hard to see in the GIS system because we just view the content of the file, the geometry, on a white surface. And for example, if an archivist should be sure that this is the GML file a user has to have or has asked for, how will this archivist know that? A way to do that is to put in a background map, which I've done here. And now you can see that these protected areas are placed in Denmark, in the part of Denmark mapped with the red square down in the corner. And if this background map also had attributes like names of the towns or lakes or roads, then it would be much easier to identify a specific protected area. A third lesson learned is that you can also, or we do, use background maps for visual validation of the geodata SIP. And that's because it's very hard to validate these coordinates just by eye. And again, as an archive, you can ask yourself, if you allow all kinds of coordinate and reference system, will you have these background map for visual validation? Let's give it a try. This is a coordinate. Can anyone tell me where this coordinate is placed in the world? I can tell you that it was actually a position of a Danish road that we used in our manual for creating submission information packages with geodata to the archive. I don't know if we have an answer in the chat, but I will go on. And now you can see, now I've put in a background map for this coordinate. And as you can see, this Danish road is actually placed next to Africa. So we should have used a background map before publishing this manual online. So this is a mistake we made that just stressed the need for doing this validation of geodata. And this is the right Danish coordinate, the green one down there for this Danish road. The fourth lesson is that automated validation of the geodata SIP is definitely necessary. We can't do this visual validation all the time or for every coordinate. Why is the automated validation necessary? Because export of data to this submission information package and transformation between coordinate and reference systems do go wrong. And unfortunately, we have another experience of that. I will tell you a real life experience. We migrated geodata from a shapefile in an original CRS to this CRS that we require. And the result was this, and this is a reconstruction of data, and it shows you the positions of shipwrecks in the Danish Ocean. And honestly, I didn't even bother to use a background map for this validation because I could see that this was indeed the coastline of Denmark. So it looked quite right to me. However, our automated validation tool that we do have in Denmark told me that some of the points were positioned outside the Danish borders. And when I did put in a background map, this was the result. And I could see that we had definitely not done a lossless migration of these data at all, because all the points had been pushed to the right during this transformation of the coordinates to the required coordinate and reference system. And luckily, we had developed an automated validation tool for geodata. Otherwise, this would be the data we would hold in the collection today. This is the test that the validation tool makes. It tests whether all the coordinates in the GML file is inside the blue square here. defined by the lower and upper corner in the GML file. And as you can see, some of the points are outside this blue border. Yeah. And now we have done another migration using the FME tool, and data looks correct in our collection. A fifth lesson is that we believe that we need to reach an agreement upon the best practice of placing geodata in the E-ARK information package, because this will make it possible to develop a tool for automated validation and migration of the geodata. And to illustrate this point, this is a figure from the E-ARK specification for digital geospatial data records archiving, the E-ARK geodata format. And it's showing one example of what the structure and content of the information package could look like if it contained vector geodata. According to the E-ARK geodata specification, it can be done in many different ways depending on the resources and documentation available. And machine readable metadata like attribute definition is not mandatory. What you see here is under geodata, there's the boundaries GML, that's the GML file with vector data. And to your right, the metadata, there's a boundaries XML file, and I believe this is the schema file that validates the GML file. Also, you see under technical documentation, the attribute definition document in a text format. And a text format might be machine readable, but it's very hard to validate if this text file don't have a very defined structure, or this kind of attribute definition file always is called, has a specific name. It will be hard to validate if there are no rules for that. You can also see a visualization JPEG file. I don't know what it is, but it could be a visualization of the coordinates on a map in a GIS system. And you can also have some context documentation, for example, a project report. Maybe this report documents how these geodata were measured, collected, or something like that. This is another example, my example of how you could structure the content, or how we would structure the content maybe at the Danish National Archive in the information package. And it looks quite alike. The difference is that this boundaries XSD file is the same as the XML file we saw before. But in this one, we include machine readable attribute definitions, because the schema file does have a structure, a well-defined structure and elements names that makes it possible to validate the content of the GML file and of this schema file. So, and I have also converted the text file to a TIFF format just to illustrate that it's good to have this documentation next to the schema file, but it's hard to validate automatically. So this is just the kind of discussions that we could have. What is best practice for structuring an information package with geodata, so that we can develop a validation tool according to that. Yes, lesson 6 is that we mean that you should at least require one attribute related to the geodata or the coordinates, and that's because coordinates without attributes describing them, they're just points, lines, and polygons without meaning. And to illustrate that point, this is what I mean. I mean, what is this? That's just a figure. There are fine coordinates, but we don't know what this figure shows. So the point is that geodata is not just coordinates, but also the attributes in the GML file that gives the coordinates meaning. And this could be, for example, the type of geometry. What does it show this is a protected area. Maybe it has a category, this is a lake, and maybe it has a name, Great Lake. Also, it's not enough to have these attributes in the GML file. You should also document or describe these attributes because this enables a user to understand and use the geodata in the future. And to illustrate that point, here's an example of a GML file that is not described, where the attributes are not described. And my question here is, what is liberty? What is type 3? And what are the dates for? There's an edit date. That's great. But what is the other date? Is that the date that liberty was born, or that the date when the points were measured? I don't know. And if you don't describe that somewhere, it will be hard to use these data. We will just have dates from a calendar and numbers from a number system. And these attributes can be described in the schema file, which I showed you before, the boundaries XSD. Yeah. Lesson 8 is an advice to use widely implemented standards as preservation formats. And of course, that's not new to anyone. It's part of the E-ARK specification as well. But the experience from the Danish National Archive is that the first geodata format that we used in 2010 was a Danish subset of the GML specification. And it was just very hard for the data creators and the producers of the submission information package to submit in this format. So in 2016, we changed this to the official GML standard 3.1.1. And that's also the standard, or maybe a newer version of the GML that is used in the E-ARK specification for Hectordata. Also, we've learned during these last 10 years that it's quite challenging to limit and define the content of a geodata zip. And maybe it always is for all kinds of data, but it's maybe a little bit more challenging here, because geodata is often open data that is widely used and reused in many systems in the Danish public administration. And I won't go into detail with this one, but a principle that guides us is that geodata should be submitted to the archive in the context where they were used and by the authority responsible for this data processing, the use of this data. We see examples in the Danish public administration that a lot of the geodata services use the official ortho photos, the flight photos of Denmark, as background maps. And of course, they should not be part of every submission information package transferred to the archive. We will just submit them once. But in other aspects, we certainly archive the data in the context that they were used. And finally, after 10 years preserving geodata and having a dialogue with the Danish public administration, we now have a good overview of the different types of geodata in the public administration. So it takes time to get this knowledge about what's out there. And this slide shows you the 7 categories or types of geodata that I have made of our knowledge. And what you can see here is, there's the 2 first category types are the raster data, either the digital image or the grid file. And at the Danish National Archive, we lack a preservation format for raster data. So we will look into that in the near future, the next couple of months. Also, the 3rd type, the vector layer geodata file type, is actually the type of geodata that the preservation format we have is quite suitable for. It's suitable for small vector data sets, smaller than where the GML file can be smaller than 1 gigabyte. And there are data sets like that. It could also be a small database with geodata. But the new types we see or haven't, yeah, we have met them, but we have just split them up into GML files with 1 gigabyte. But we also see that there are large GIS systems out there, and they often contain databases with geodata, very large databases with lots of attributes and historical temporal geodata as well. And this is a challenge for us because when we do, as we do at the Danish National Archives, split the data into small GML files less than 1 gigabyte, this reduces the user's search options in the future. Then you can't really search across temporal data or cross attributes in the large database. You can just use the little GML file. And the reason that we have this rule that 1 GML file should, the size of it should be less than 1 gigabyte, is that it's quite hard to validate a GML file because you can't open it in a text editor if it's too large, and the user can't really open it in a GIS system if it's too large. So yeah, for access purpose, it's a good idea that they're small, but for preservation purpose, we think that we should have a look into, can we preserve this kind of large database geodata in another kind of way? And finally, there's a challenge with unstructured geodata. And unstructured geodata is when you have a system with all kinds of geodata formats from different kinds of system in one system. For example, if they are filed in a record management system, building cases or something like that. At the Danish National Archive at the moment, our requirement is that you should just convert these geodata to the TIFF format, and that is like disposal, isn't it? That's not really preservation, so we should definitely look into that challenge in the future as well. And the challenge is also that we can't use our present preservation format because we have a lot of requirements, and it's quite hard to validate if you have many geodata files that are validated by different schema files and not just one that can validate, yeah, a GML file with one structure. Yeah. It's quite complex, but at the end of these slides, I have put in more slides for you if you're interested to look at some of the questions that we ask ourselves to solve these challenges in the future. I don't have time to go through them. I think my time is up, and this is my last slide. I'm, yeah, to do it quick, I'm looking forward to working with Gregor on selecting a suitable preservation format for raster data. I mean, we all have the same challenges when preserving geodata, and luckily we do have the E-ARK project working on a common European standard for preservation of geodata. So let's work together. And also, this is just to sum up what I've just said, but our input to the specification could be that we try to agree upon best practice of placing geodata in the E-ARK information package, and that the message is that we do need a tool for validation, automatic validation of a geodata set. Yeah, then we recommend that you describe your geodata and limit the allowed CRS. But maybe you have other opinions, and I would very much like to hear that. That's all from me.
Thank you very much, Ann-Kristin. It was a very extensive report on your usage. I definitely will need to go through it again to kind of answer a lot of issues that you stated out, and I have the answers for them. There were some misunderstandings from the GeoSIDs, but anyway, this is very, very useful. And let me ask Kristi if you have any questions.
Yes, we have got one question for Ann-Kristin.
Okay.
And it's about storing the geoarchival information packets.
Yeah.
So, which software does the Danish National Archives use to store the geoarchival information packets?
When you mean the software used, I think we have developed our own software at the moment for the storage system. Is that the question? The storage system or the, yeah. Because we have developed that ourselves, but we are looking into other solutions on the market at the moment. Yeah. Does that answer the question? Or?
Tom Dirks would like to comment on that.
Yes, thank you. Just muted. Yeah, we are in the National Archives, and the Danish National Archives are looking into archiving geo packages, and we're looking for ways forwards. The system we use now, or so-called eDepot, can't handle any geo archives without a very extensive rebuilding. So I was looking for which, but you build it yourself, so
yeah.
I was looking for pointers.
Yeah, and if you mean, do you mean the storage or do you mean the information package that we use?
Well, both actually.
Yeah, at the moment we have a Danish version of the Geoarh format, which is also a preservation format for databases.
Yes.
And we have had this Geoarh DK for 10 years, and so the information package is actually structured in a way that a lot of the attribute definitions and also documentation about the geodata is in a database format, in the Geoarh format. And then the GML files are placed in folders in the structure. And there's a link from a column in the database in the Geoarh format into which folder the corresponding GML file is placed. And that is quite important to be able to search for the correct GML file for a user. So that's a point I would like to share with you as well. This, how do you, if you have an information package with a lot of different GML files, how do we search for the right one? Do we have the Geoarh format as well in the information package with registrations of these GML files, a name of it or something like that? Or how do we actually find the right GML file in the information package? But that's the information package, and the storage system is one that we have built ourselves. Yeah.
Okay.
I don't know if any of my colleagues are listening and would like to answer, and maybe we could give you an answer in text as well later.
Yeah, maybe we
details.
could write some mails about it, because yeah, that would be great. I'm helped for now. There's no such thing as off-the-shelf system ready to roll.
No, yeah.
Right.
Right, thank you.
Thank you, Anne.
Ann-Kristin, may I ask you some general question?
Yes.
Are vector data deleted in the production system after they are delivered to the Danish National Archives, or are they still retained by the data producers? Thank you.
Yeah, you can say they can be deleted if they, as geodata rarely holds personal information, but if it does, then after it has been transferred to the archive, it should be deleted. So all the original data should be deleted out there in the real world at the agencies. So yeah, we don't preserve the original data file. I just told you that the archive migrated from a shapefile to our geodata preservation format. But we actually did delete the shapefile after that. But in the future, we will look more into because the E-ARK information package allows us to preserve both the original file format and hold a preservation file format at the same time. So we're looking into that now. But up till now, we have deleted all the original data formats, also vector data. Yeah.
Okay, at this stage, I would thank everybody for the questions. We ate up the 5 minutes for the break, but anyway, I think.
Do you have one question, Gregor?
Yes.
Do we have time for this?
For the break?
For the question. There's one more question for Ann-Kristin.
I would ask you to just write it down so we can answer it later, because I see there's a lot of questions that should be addressed in the DLM forum work group potentially, because this could be a long discussion, and I would like this discussion to be to take place, but not now. So let's put the question to the parking, and maybe we can address it later on the DLM Geoforum meeting, maybe as a solution to discuss these issues. The debate now have finally started, would be maybe to create some working groups in which people would discuss this, and this is how we could get a good European best practice. So this is my
idea.
Yeah. Okay, so if you guys agree, we would just continue, because I think it was important to answer some of these questions, but anyway, if you need a 5-minute break, you can take it anyway. The point is that we need to end early because we have the DLM meeting afterwards, so we try to respect the timeline as much as possible. So in light of that, I will now stop your window sharing, and
thank you.
Yeah, so thank you very much, Ann-Kristin. It was a great presentation.
You're welcome.
And now I would like to introduce to you Mr. Roger Brackin, who is a colleague of mine that we worked together, and was kind enough to prepare a presentation on a standard that he helped develop that actually discusses or describes the context of geodata and how it was used, especially if it was used in the different environments, or it should be transported to different environments, which archives certainly is such an environment where we export data from the original system to the exchange system, which the archive definitely is. So Roger has an MSc and has been involved with the geographic information systems for over 30 years. He had a major role or lead on projects for the UK Ministry of Defence and NATO, the Registers of Scotland and UK Land Registry, the US Department of Homeland Security, the European Space Agency, and more. He is an international advisor on the subject of spatial data infrastructure and a regular participant in standard bodies. He has contributed to over 20 international standards and chaired working groups on several of these, Open Geospatial Consortium, and co-chair of the OWS context. So welcome, Roger, and off you go.
Thanks, Gregor. Can you hear me okay?
Yes, we can hear you.
Right. Yeah, so thanks for inviting me and for reading off my CV. That's quite kind of you to go through it. So hopefully this is of interest. And Gregor mentioned this to me, having looked at this standard, which I worked on a few years ago. I can't even remember how many, but it's been slowly making progress, and it's in use in a number of major organizations. And it's got some relevance to the archiving world. It's called OWS Context. So a bit of background. So what we're going to go through today is some background and use cases. I'm then going to talk about the design of this standard a little, and then well, we'll touch more on the relevance to archival towards the end. So the presentation looks to some degree at how geodata can be saved and recovered in the long term, and some of the issues that we know, that at least I've been made aware of around archival, which are also true operationally as well for the use of OWS context in its main use, are that GIS system contents are not easily preserved, and the data to some degree can be preserved, but often the data is encoded in very specific, sorry, the description of where the data is, what it is, you know, what you're displaying at a given time is encoded in very specific formats inside a GIS. So it'll can only be read by another GIS of the same vendor or technology. What we were looking for is a way to distribute information, or not just data, which allows you to pass that subsidiary information around as well as just the data itself. And the idea of doing that, so, and I'll touch on the use cases of this, which are really about sharing geographic views or outcomes between communities, also holds up quite well in the archival use case, because it's got a bit more longevity than the GIS system itself. OWS context is a way, it's an encoding standard, so it's got two encodings, but it's basically a description of how to connect together various resources, mostly geographic at present, but the standard holds up with non-geographic resources as well, in a sort of project or a collection or a bookmark or whatever else you'd like to call it. And as such, what it allows is you to have multiple views on a given set of information without a lot of redundancy of duplication. So you don't have 10 copies of the map, you have one copy of the map and several views with different overlaid information on it. And this has turned out to be very relevant to passing around environmental data, which tends to be very big. So you want to show a view or some environmental data with an overlay, or if you want to send out an operational picture of, say, a fire or an emergency services event, some sort of national emergency, you can pass around a relatively small description, and as long as everyone has access to the data, then that description allows you to pull up the same view in one location or another. And so it's really been taken up by defense agencies in the UK and US, and also national mapping agent, or for people like FEMA in the US, to allow you to pass these views around. There are proprietary versions of this, as I say, in things like when you're using a web map in an Esri client, you know, on the web, you're doing the same thing. But the trouble is it only works in that client, and QGIS has an answer, another GIS. So you're always struggling against not being able to share it very widely. So the very common use cases are what we generally call shared situational awareness. So you've got a guy in a command center, understands what's going on. He can set up a view and pass it to a responder on a mobile phone, and they can immediately see the same collection of information. But it is also used, for example, to describe when you've done some analysis, some processing of, say, satellite imagery. You can pass the process you've used, but also the results onto another user. So they're the sort of mainstream uses. There is a use, actually, the middle one, cataloging. There is a use which actually addresses one of the comments by the previous presenter, where you had very large GML files. Instead of that, you can fragment those files and provide a catalog of the individual contents, so that you don't have one very big file. So there's a few additional use cases which are relevant maybe, but it's also been used to provide what's sometimes called a recipe so with a context document, it references multiple sets of geodata, and what you can then do is say, build me a small package with just a small geographic area to take onto my mobile device. So if I lose network connection, I've got it. And as you know, there's other use cases, including the archive one. You know, all of these are evolving for context. So, and this is generally the sort of badge, as it were, story. In general, OWS context documents are passed around different technologies, different communities, and organize views in those communities. But it can also reference data, or indeed embed to some degree geodata. So there's quite a few options in the way it's used. It doesn't have to be web services. So this is an example of an OWS context being used. ESA decided that they would provide a wide range of thematic environmental analysis for their satellite imagery. And what this does is allow you, on the one on the left is a collection of catalogues of specifically relevant imagery. On the right is a particular environmental zone of interest. And everything in this picture, including what's listed at the bottom, is described in an OWS context document. I mean, it references, you know, the geographic content and the textual content. And so, because it's very easy to create, you drag and drop layers into a view, and then you can publish a context document immediately onto a web server. It means that they can construct multiple views with very low overhead per view. And another application similarly is a forestry application by CREAF, a Spanish environmental research organization, and they're using it for a very similar purpose. And their GIS system, instead of being a web page, they use a GIS system to load a view of geographic data and present it. And then they also have a web viewer that allows it to be displayed. This is the one, you know, most, I say, close to my heart, maybe the one I've worked on the most, but this is a web portal for the Ministry of Defence. And in this case, you know, a context document is used to store a geographic planned route for, say, moving military vehicles, and it then shows the terrain cross-section. So all of this is described in a context document. And you can have a web page with multiple of these views and just pull it up. So this is really the simple story of why we got there, because, you know, we had a whole load of users on one technology accessing all sorts of web services, and we also maybe have people using different technology like mobile also accessing the web services. For years, this has been the way you pass around that view. So, you know, we've got a couple of maps on these URLs. This is the geographical area. So you have to type all this rubbish in on your client in order to see the data that the person on the left is looking at. So we'd replace that with an XML document, which you can email around, which allows you to then access the same content without all the fuss. So on the phone, it looks like an app. You click on it, it opens and shows you the view with the information you need. And it also, at this client, you can generate an export. Once you've set up your view, shared it with people online, you can then say export, and it will build you an offline package in another open standard, which can be sent or downloaded by the mobile user, and then they're completely autonomous. So what's in a context document? So let's touch on the anatomy. So we've got, everything is optional. So you've got quite a lot of flexibility, but commonly you might define a geographic area of interest with a coordinate system. You might also define a relevant time range. And then you might define a series of layers like some terrain, roads, and so on. So this whole collection references data on a server, on a disk, you know, on a package that you've delivered. So it can be like a manifest or a view in a data package. And all of this is easily described. So maybe let's walk through those bits quickly. So we've got the context itself, which is a information packet in the document, which has got metadata, area of interest, time range, and so on. Then you've got a list of resources, which are ordered. I'm talking about visualization, but it doesn't have to be visualization that this is relevant to. It's really just saying there's an ordered list of objects. And these objects can be active or background. So one of the tags that comes with a document is to say, if active is being visualized, that typically means display it. So this layer might be displayed, or it might be there in case you want it. So you provide some extra data alongside the main data to view. So just that context story, you know, here's the area of interest, and it would look, you know, what you would get when you load a context document would be actually quite like what Zoltán presented earlier. You know, when you open the context document set up for a king, you would get the time range automatically set to that by default. And equally, it would zoom into a given area. So that's the sort of idea. You can have multiple views in that way. So looking at resources, as I said, these can be anything like map, track overlay, a particular piece of information. But if we jump down to the next level below that, we then have this idea of an offering. And an offering is a resource. So let's say the map might be available online as a web service, but it might also be available offline as a data set on your device. That might be more out of date, but when you load the context document, a common practice is if it's online, it will go to the online offering. If you don't have an online connection, it will drop back to the other alternative. And this offers quite a lot of flexibility. You can have multiple encodings of the data. There's no limit connected to each resource, and the client can choose which one it wants to look at. And typically in an offering, there's content, but there might also be some styling rules. So this might be a Google map and simple styling, or some GML and a very complicated styled layer descriptor description. So, you know, there's lots of options here. And one other thing I should say about both the encodings of OWS context is they allow extension outside of the standard. So you provide a URL and a web page where you define the extension, and then you can just use that URL to reference the extension. So it's very easily extendable by communities. There's two encodings. So one thing about OWS context is there's a document which describes the content model, conceptual model of the content. And that is the URL here if you're interested in more detail. And then we define two encodings, Atom, which is an XML description, which is commonly used in RSS feeds. So it's a very well used standard. And also GeoJSON, again, this one is used, the GeoJSON is commonly used for browsers. The XML one is commonly used for transfer. And both encodings can semantically very close. There is a couple of differences, things you can't do in GeoJSON that you can do in Atom, but they're very minor. So it means that you can easily translate between these two automatically and allow users to use whichever one they want. It is ASCII, so both of these, of course, are text. So that does help the long-term protection. And they don't tend to be very massive. They're mainly references, so they're very easy to transfer around. Yeah, I don't think we'll get into the detail of this, but these are some examples. And there's quite extensive examples on a site that I'll give you a link to if you're interested in looking at it. So how does this affect archival? Well, as I said earlier, the archival use case is really is quite important in terms, and there's been lots of discussions, I understand, around approaches to archival of a GIS package. And that often revolves around, for example, an argument to use virtual machines. And there are obviously issues with this because, you know, it does depend on you having the technology to recreate that virtual machine. Whereas at least if the description is basically in a text form, it does mean you've got more chance in the long run of recovering, you know, because the format is at least clear, visually clear. You can look into the document. So the context document does have some merit in supporting a longer term recovery. And this is almost a bigger issue when it comes to a problem where you've got not just one organization, but multiple organizations with data. You know, if this is what you wanted to archive, then the context document, it can describe how to bring all these pieces of data together. And effectively, actually, you could pass that context document to a processor, and it could harvest the data that relates just to, say, the geographic area of this context document and pull in the actual detail from each of these sources and bring them together to give you a data package which could be archived with in effect a manifest which describes why you wanted it and what area it related to, you know, and its purpose, truly the context, which is the reason for the name. So hitting on what the benefits of a context document are, and these really relate to some degree to the identified requirements of archival, which Gregor kindly passed on to me. So probably not so important for archival, but more for general use, is it can be passed around. So it's very easy to create a context document, pass it around a community which has access to the same data, and review whether it's right, whether it's got everything in it. Having done that, you know, it could then be converted or archived, but it does give you a preview, I guess, capability. It is vendor and technology independent. It is supported by an open standards body and a published specification. It does have easy extension points, extensions designed in to allow other communities to add formats or even encodings in, you know, with the same conceptual model. And it does work with very simple problems, but also is quite scalable to more complicated encodings. For example, as we've talked about, including time or other, you know, echelon-based data, visualizing complex data structures. It's also very robust. It's built on Atom, as I said, and GeoJSON, both fairly well recognized standards, and it can be validated. There is an online validator actually that the OGC support as part of their test framework. So, and there's an accreditation process. So you can accredit a piece of software as compliant with the OGC, with the OWS context standard. You could argue that it's not highly pervasive, although Atom and GeoJSON are. But a valid context document is a valid Atom and GeoJSON document. There's nothing, I think the lady earlier pointed out the issues of having profiles which are special. Anything that reads Atom can read a context document. It won't be able to recognize the geographic bounding box, but if a GeoJSON reader could, but it can tell that it's an entry in Atom. It is a resource is an entry, so it can tell there's some data. So even a browser can do that, and we tested that. Google, out of the box, understands the structure of a context document. It also represents an exchange format. So one issue is maybe it's not, a GIS system might not use it or be able to read it internally, but it can often be converted to something a GIS can use, and it's much more visible. And as I said, it's stable. It's a stable version of both of those standards. If you want more information, one thing I missed a trick watching Zoltán is I missed the trick of providing a demonstration, which I could have done. But if you want more information, there is a website, owscontext.org, and the links to the standards earlier on. In here, you'll find the implementation guide, which shows the examples I put through. It's got some example context documents in it and other information. So hopefully that's useful. So really I don't know if there's any questions out there. I've burnt quite a lot of time, but there's still 3 minutes, I think. So.
Yeah, thank you, Roger. You still have 5 minutes for questions before
right. Okay.
I start. So,
okay.
So Christy, did we get any questions for Roger?
Not right now.
Okay. Well, then maybe I will comment, if not pose questions, because I understand it might be difficult because Roger is coming from a very technical domain, and the archival domain is usually a bit different. So if you can imagine, you can use this context for publishing DIPs of the resources that are stored in your archive or in any other archive. So people don't actually need to access to your data, but they just need to access these projects and so on. And I guess that this type of information could also help us store, as Roger said, the issue of big vector data sets, to store them as tiled vectors or something like that. Is that correct, Roger?
Yeah, so it's used in the US Geospatial Agency, USGS. It's used to have grids of geographic data, so it describes the grid, and each of those grid squares has got a geo package, which is a little block of data purely for that grid square. So there's a number of uses around cataloging that it's been used for. It does allow you to have descriptive information in there and other things, which and maybe some overlay graphics which relate to that individual item, so you can annotate, for example. So
yeah, so Roger also showed the slide where we saw that we now talk about storing geodata, and the second layer is actually how to store the applications, because we will not be storing GIS applications, GIS systems, but this is
this one.
Yes, this one. This is actually a standard that could be used for the dark blue box, right? For the GIS tools.
Yeah, that's its main target. I mean, I didn't really describe it very well because I thought I was running out of time, but let's take, so in ESA, they run some processing on a set of satellite imagery or some environmental data, and that generates some results. So they want to pass on, the picture of the results, but also what processing they did and what the source data was and so on. So someone else could rerun the processing later with some different parameters if they chose to. So that sort of use is very common as well.
So this could also be used to show us the provenance of the results.
Yes.
So actually how the result came to be based on which data and using which processes. So if this end result has legal consequences, which is very often in the archival domain, we know how it got this way.
Sure, yes, that's exactly. And if you can be, the lady earlier was talking about coordinate transforms. Quite often later on, you discover there's a better transform than the one that was used at the time. So, this can describe what the transform was used, what the source data was, what transform was used or process was used, and show point to the result. but that allows you later on to go back and say, well, I know what data was used. I can rerun it with a correct transform or a better transform and generate, because I know, you know, I can see what they generated. I can see what process they used, and I can see what data it came from. So.
Okay. Still no questions from the participants, Christy?
Yes, we have one question from Domenico Ruggeri. Does the OVS context has to be put alongside a GIS file rather than inside it?
Yes, that's the most common thing to do. So you would usually have, if you have the data as a data, you know, as files, let's say shape files, for example. So in an OWS context, you can reference a number of shape files. So there would be an XML document or a GeoJSON and a series of shape files next to it, and the context would point to them, for example. But there are cases, for example, GeoPackage, where the context document can be put inside the data package and still available, you know, could be pulled out, but it can be put inside. So think of it as almost a manifest or a series of manifest files, because it's really different views that go with the data in the same way as metadata often goes alongside the data.
Okay, I hope this answered the question.
Yes, thank you.
Okay, excellent. So I would thank you, Roger, very much. If anyone has any other questions, if you come up with any other questions, please send the message to Christy, and we will send them to Roger to answer them in a later time.
No, thanks, Gregor, for letting me present. And I know it's a bit out of the domain, but it just seemed relevant. And hopefully, once it's sunk in, I'm quite happy to answer any questions.
Okay. So thank you very much, Roger. And now I will go to my presentation. Okay, just a minute. Okay. So do you see it now?
Yes, we do. It's your presentation.
Okay. Excellent. So let me also present myself as I did the others. So I'm an independent international consultant with more than 20 years of experience in the geospatial domain. I used to work in a GIS company that provided solutions for different customers in government, businesses, and so on. And later on, I have the experience of working in the Slovenian National Archives on the E-ARK project, where we started developing specifications and pilots on how to preserve geodata that was digitally created, so digital-born geodata. As a member of the DILSIS board and the E-ARK projects, I actually contributed to the specification document that Anne-Kristin was talking about. And I'm also creating courses and the training material for the archives and any businesses who would like to implement this e-archiving building block specifications that are now a part of the CEF framework for the digital economy in Europe.
and I'm trying to create a community of people who are interested in preservation of geospatial data within this Geoforum and with the events that I help organize. So let's go to the agenda. What's the agenda today? First, in the title, I said that what's the role of geospatial data preservation in machine learning applications? The first thing is why machine learning applications? Why the data-driven economy? Then we'll talk about what is AI or artificial intelligence, machine learning, deep learning, and relation to geodata. Then we will look at some GeoAI examples and its applications. And we'll talk about the challenges with geodata usage in artificial intelligence applications. And of course, in the end, we will talk about the potential we have in the archives, because as we were talking about data-driven economy, data is becoming more valuable than oil, as they say, and the archives are going to be the largest data centers in the world in the near future. So the why for this integration of geodata preservation and AI is actually the data-driven economy, where everybody's saying data is the new oil. Now, how do we know that this is true? First, European Commission identified that they need to have a data-driven economy strategy, and in 2014 they provided strategy papers, and this is a directive, or this is the direction that we are going in. Gartner Group says that in 2017 that by 2020 artificial intelligence will create more jobs than it eliminates, because people are afraid of automation. But on the other hand, we see that especially in this time of pandemic crisis, we need to have access to digital resources, because we cannot move around if we are in quarantine. So accessing things digitally or having some other tools help us decide on what to get helps us with the artificial intelligence. And of course, especially because in the 2019 European legislation published an open data directive that wants to give incentive to businesses to reuse the existing data to provide new services, to provide new solutions based on existing information that is available. And this is where we can talk about the new relevance of the archives in this data-driven economy. As Zoltán said in the beginning, we need to find and reinvent new ways to serve the community in order to stay relevant. And this is definitely one great potential we have. So now let's go to the definitions of artificial intelligence and what this is. So let me have a disclaimer here first. I'm not a data scientist. This is based on my investigation of this topic for the last 3 months. But basically what I found out is that artificial intelligence is a set of different approaches together. Actually, it's something that enables the computers to think. So we don't need to program them as robots, but they can come to their own conclusions based on algorithms and huge amounts of data that are either past data or real-time data. Then a part of artificial intelligence is actually machine learning. And this is where we teach the machine how to react, how to respond, how to identify things using statistical tools using which we explore the data in a supervised or an unsupervised manner. So this actually allows us to solve the problems that are too complex for a manual approach. As you will see in an example later on, it's really a huge endeavor to go through 500,000 records and identify some trends from that. And within this machine learning, there's a deep learning type of approach where we have a approach using multiple neural networks. And this actually means that we use a lot of data to teach the machine to create a memory or some knowledge that we know how to use in the future. The examples of this are computer vision, where they identify certain elements, they identify certain patterns in space, and you can also imagine that we could use this to identify and vectorize the existing old maps, because we can teach the machine to see the topographic signs and to somehow identify the features. Oops, sorry. To identify the features from maps compared to real-time features, and do it much faster on a greater scale. So main benefits of AI are especially feature and object detection. You can see here from the satellite image, the trained algorithm identified different vehicles. You can create predictive analysis for voting in political cases. You can classify objects by different classifications, identify clusters, detect anomalies, and basically the greatest ability is to be able to sort through a huge amount of data that gives us new insights into what is happening. So just like Zoltán showed us how we can see that some elements of the history books cannot be accurate because the same person was not in the same place 200 kilometers apart, 2 days apart, we can also identify other elements, combining them all together. So let me go and touch on the topic of neural networks, especially because this is one thing that also requires a vast amount of training data, and a subtype of neural networks called recurring neural networks is used for creating predictions and uses a lot of temporal data. And this is where archives could be a good source for such applications. Now, let's look at what real-world geo-AI applications actually are. One, and the oldest one, is actually the change detection, where we compare different satellite images or maps to identify new objects or when they were created. And this is how we can also create derived maps that identify elements in the environment. In the agriculture, we use artificial intelligence based on huge amounts of data, from meteorological data, soil data, data on crops, and so on. And this is also where we see that we need some geospatial elements in order to receive good results. Then you all know this map, healthcare. In the analysis of pandemic, AI was used to analyze all possible flights from different locations to different parts of the world to kind of predict where people who might have been on the same plane that people who were infected were flew to, so we could see what the artificial intelligence can help us here with. The other thing that Geo AI applications can do is retail, where we can use the geolocation from the metadata of the phone. Everybody who has a phone has a sensor with a GPS, or its geolocation is derived from a triangulation between the cell towers. And this is how the phone companies actually have a new data set providing us the amount of people being in a certain location at a certain time. This is how businesses can then identify the clusters of greatest amount of people and identify when they would like to give us some lowered prices and special offers and so on. Smart cities are also very integrated with location because we need to use the geodata about infrastructure, buildings, road infrastructure, green areas, population, and so on, and combine all this to a smart city system that can operate a bit more efficiently. And of course, autonomous vehicles use computer vision and existing road infrastructure geodata to somehow create this service. And if we just start combining this to our own new neural network, we can see that if we combine change detection and agriculture, we can have a lot of good solution that is already being used. So geospatial data is being used in banking, finance, for forecasting the crops, for trading on stock markets, and using business intelligence to forecast better sales in the future and to plan the activities of businesses in the future. Then the next combination would also be combination of agriculture, healthcare, and retail, or let's say metadata on location of people. So we could identify environmental impacts based on healthcare data and location of people on that location, and maybe amounts of use of pesticides. The next option could also be disaster response, which is also something that Roger mentioned, where we could use the healthcare information combined with all this other information of the same application. But to go to a very specific example, let's see how old geodata was used to predict traffic accidents in an American city. This is an example from a 2018 Esri user conference. You can see the YouTube video here. I will also post it in the chat later, and you will also be able to see it in the slides after we publish them. And in this example, they used more than 20 different parameters to identify risk assessment of possible traffic accidents in certain parts of the city. So you see we have temperature, wind speed, visibility, snow depth, time of day, year, month, and so on. Road width, road alignment, speed limits, sun direction, traffic information, proximity to billboards, and so on and so on. And more than 80% of these elements are based on geolocation. We need to know where the billboards are, where the roads are, where the temperature sensors were, and so on. So in this case, 7 years of data was used, where they used 400,000 accidents on 500,000 segments of roads. And this is something that would be impossible to manually analyze. But they used this to train the machine so that it was able to predict the traffic accidents in the future based on time of year, sun, weather conditions, and so on and so on. And this gives us information how to use old data that we archived properly in a way that can benefit us for the future. Now, what are the challenges with using geodata and machine learning? Currently, as we also discussed today, there's a problem with a lot of proprietary formats. This is still a very computer-intensive operation, so this also means that we can expect this to be overcome over time because the computers are getting faster and faster. Currently, most of the data for such a multivariant analysis is stored in different siloed systems, like different ministries, different agencies. Every ministry or agency has a different GIS vendor, GIS system provider. The formats are different. Maybe the policies for giving out data are different, and so on. We're still in the beginning of this data-driven economy, so we lack the AI experts. And of course, if we have data like Anne-Kristin showed that we have no context about, we don't know what that column was talking about, a news column or a column on a building. So to summarize all that, we can see that basically the problem is accessibility. So the data is not ready for machine learning. And this is where our greatest potential comes out. What is the potential of geospatial preservation for the AI? First of all, if we use the e-archiving building block guidelines and we create archival packages using the suggested long-term preservation formats, we could all have similar or a very small number of long-term preservation formats that help us with the use of data in a wide network of resources. The archives are very keen on getting the data documented and with all the context, all the metadata. In order for us to validate them, we need to have them in a machine-readable form, just like Anna-Kristin said, and so on. And this is also helping us for the output. So the next thing is we are looking at the availability of a long time series in a couple of years, because as we know, it's not usual to archive geospatial data after 40 years if it's in a digital form already. Most best practices say in 5 or 10 years. So we can see we already have more than 40 years of geospatial data in digital form, because that's how old the GIS is. And if we can offer this through an interoperable gateway, if we can offer this through a system of archives, may it be in national archives, it could be an archive of a mapping agency or archive of an environmental agency or any other archive. But if we can offer an interoperable accessibility that's based on standards, then we can help the community and the businesses to invent even more business applications or give us even more solutions based on machine learning and AI. So this is the, as the archivists already know, the archival process based on OIs, where we need to talk about pre-ingest, how to prepare the data, and access. And why are they both blue? Because they both have the same issues. On both sides, we need to have a possibility to extract or serve data that is available in a machine-readable form. It can be validated with an application, and it can be searchable with an application. So we need to see how these things operate together. And this is what can be solved using these e-archiving building block specifications for geodata, or called geosits, that are still in development in order to be able to reuse it in the archival domain. So what is available right now? Right now we have the geosits, which is the geo content information type specification that is currently available on this link. And I would kindly invite you, if you didn't already download it and read it, if you are interested in archiving geospatial data, please help us develop it, because we are doing this based on some experience, but the more of us that will contribute to it, the better the specification will become. We're currently in the development of 2 more documents. One is the GIS SITs. So this is where Roger's presentation comes in very handy, because this is one of the standards that we will propose to document the GIS systems when we want to document them for later reuse. And of course, implementation guidelines, where we want to give the archives or anyone who wants to reuse these specifications guidelines on how to approach this, how to store the coordinate systems, how to set up a search environment so that you can find geodata and view your geodata in an online application or from your home application and so on. And this is also where we need your help, because you are the ones that will implement it, and you are the ones that have the questions. I already noticed that when I was writing the specification and Anna-Kristin and me were discussing certain elements of it, I saw that I wrote it in a geospatial thinking way, but I would also need to write it down more for archivists. And this is where I need your input, because we need your questions to actually create good implementation guidelines. Because sometimes things are very clear to me, but not to someone else. So what can you do? I would ask you to review this documentation and tell us, is there anything that you need us to clarify? Are we covering your needs or not? Did we forget something? Do you have any other suggestions that we should use? We are also creating training material, and we provide courses, as some of the members already know. We had some courses in Denmark and during the E-ARK project, the initial one. Last year we had a course in Latvia, and the Lithuanian archives were also there. We had the courses for Slovenia National Archive during the E-ARK projects, and we have very good feedback, because if we are talking to each other over there, we actually are able to come up with the questions, with the answers that really help your case. And of course, what else you would expect in the guidelines. So this is where the Geoforum comes in very handy, where these are maybe the parts of working groups where we see the possible discussions about the archiving approaches, what things we should add to the GeoCIS documentation, what type of training you would need, what guidelines are needed. And this is where we could mastermind using experiences from the archives that already have it, and proper questions from the archives that are planning to implement. And of course, the last one is the second GeoArchiving conference that will be in March 2021. We will shortly give you the actual date. The plan is to have it in Ljubljana, but it might happen online depending on the current pandemic situation. But I guess that this way of mingling is also working, because I think that a lot of people got a lot of information, but from today's event. So I would really like to ask you to give us some more inputs on that. So this is the end of my presentation. So I would like to invite you to give me some, to tell me if you have any questions, or if you want to comment anything on this. Do you think that the AI is the future of, it's possible salvation for the archives, or anything else? So, Christy, do we have any questions? Looks like Christy is not here, because this is the last presentation, and if you have any questions, please just unmute yourself and ask, and we'll try to work it out.
Gregor, how do you see, because it's obviously a very like complicated and somewhat new field, do you see prototyping as a way to progress it, or how do you see it evolving as a prototype, or would you go to build a real version, as it were?
Well, my idea is that we start with on two ends. So first thing is start influencing, as the archives can, start influencing all the national data infrastructure systems to include these elements of archiving, so this could help us in the output end. And the other thing is the archives that already have geodata could start serving geodata not within closed applications, which is the most controlled way, but using web services. So that this could, I mean, we could start with web services, so people could create mashups and so on. and this is probably one way of reuse of this data.
Yeah, actually, it plays to a point which comes out of Zoltán's application, which I thought was extremely interesting. But if the data he had was served as a web service, then you could actually link it into other things, and you know, to some degree, having lots of portals with data on is quite hard to integrate. Whereas if you have you know, in addition to the portal, which you need services, yes, then it allows you to link stuff together. So,
yes, and this actually is also becoming a part of the guidelines, so that the archive should think about serving the community using service-oriented architecture, because this is something that would make them relevant. Anyone else?
I haven't received any questions for you, Gregor, right now.
Okay. If anyone else has any questions, you can send them to my email, gregor@geoarh.si, or to DLM forum, and they can contact me if they want to.